So there are lots of different ways to plot in Julia, but in this notebook, 8, I'm going to show you how to plot using Plots.jl. One of the things that's cool about the package called Plots.jl is that it gives you a common set of syntax to use multiple different backends. So you can write code to generate a given plot. You can generate that plot, and then if you want to switch out the backend and switch from using, for example, PyPlot to Plotly.js or GR, you can do that without needing to rewrite any of the code that you use to generate that plot, other than one call to a new backend. So I'll show you that in this notebook. We start by saying using plots I've actually already run this notebook, but we start by using plots here to load the plots package. And then the data that we'll be using to demo plotting is this global temperatures and number of pirates data. So this gives us some data that I've thieved from the internet, where for a few years between 1860 and 2000, we have global temperatures in degrees Celsius and pirate populations in number of pirates. And what we have here from left to right in the ways that I've populated these arrays are data for years going forward in time from left to right. So here I load the GR backend, so that's the first backend that we're going to demo. And then here I'm using the plot command and the scatter bang command to plot global temperatures against the number of pirates. So what we've done here is we've used the plot and the scatter bang commands to generate an overlay of points and a line plot. One of the things that I'll have you note here is that we've used scatter bang instead of scatter. If we had used simply a call to scatter, we would have generated a scatter plot. But if we want an overlay of multiple pieces of data or multiple views of data, we would generate that overlay by mutating the plot that we created in this first call. And there are a couple different ways we could do this. Here, when I've called scatter bang, Julia has just assumed that the plot that I'm updating is the plot that I generated last. If I'm generating multiple plots and I want to be precise about which plot I'm going to use for an update, what I could do is I could name a figure like my fig, for example, and then I could say scatter bang, and I could specify that my fig as the first input is the plot that I want to update, and that would work just as well. But here I don't need to do that because I'm only working with the plot that I just created. Now we can mutate this plot a bit farther to add some extra information about what the plot is showing and what our axes mean. And so I've labeled the axes with these X label bang and Y label bang commands, which tell us that on the horizontal axis we have numbers of pirates and that it's an approximate figure, and that global temperatures are given here on the vertical axis. And the title bang command here has given us this lovely title, which shows us that this data is telling us something about the influence of pirate populations on global warming. One thing that looks a little odd here is that it looks like pirate populations are going down from left to right, and similarly global temperatures are going down. And the reason that this is a little odd is that by default, Julia is plotting whatever's on our horizontal axis in increasing fashion. Oh, sorry, I think I said that wrong earlier, that this looks like the number of pirates is going up. Yes, because Julia is plotting in increasing fashion from left to right. But actually, pirate populations have decreased since the 1860s, and so if we want to see that pirate populations have decreased and be thinking about our data from left to right, we would need to flip this plot, and then we'll see, going forward in time from left to right, what has happened to global temperatures. So we can do that flip with this xflip bang command. Okay, and so this is what we see here. Now we have data from 1860 to 2000 going left to right, and pirate populations are decreasing, as you might better expect, as global temperatures are rising. I have been told to say that this is a correlation causation joke. That may not have come across to all of my audiences, and yes, just to be clear, this is a joke. Yes, so we don't really need more pirates, hopefully, to prevent global warming. Okay, so what might we do next? What we might do next is show that we can generate very similar plots now with different backends without changing our code. So this is the code that we use to generate the plot above. Here what I've done is I've called the PyPlot backend, and now we're getting a PyPlot version of this same plot. Another thing that another backend we might use is this one called UnicodePlots, which doesn't work perfectly in this particular context because it doesn't seem to have the xflip bang command, but just to give you a sense of what a very different backend might look like. And that it needs to be smaller for you to see what's going on here. There we go. Okay, so if I make this plot much smaller, then you can actually start to see it. There we go. Okay. So that's UnicodePlots. And the final thing I like to show in this notebook, I have a bit of a lag on, I think I'm running too many things on my machine at once. So there we go. Zoom back in. Okay. Hopefully you can see my stuff again. All right. So scrolling past our Unicode plot. The last thing that I like to show here is how to create subplots in a larger plot. And we've done that in this last exercise here. So first off, here I'm declaring this range x from -10 to 10. And what has been done in this exercise is that I've generated 4 different plots and bound each of those plots to variables p1, p2, p3, and p4. And finally, I've called plot a 5th time and then fed these plots p1, p2, p3, p4 as inputs to this 5th call to plot. And I've specified how I want the layout to look of these individual plots, which are going to be subplots within my larger plot. So here when we say layout 2, 2, we get this 2x2 grid of plots. We similarly could have said, 4x1 or 1x4 to get a different layout. So that's it for our plotting story.